All right, welcome. Episode number 3, still on the set. In this episode, we are taking operations with set. And we can see that there are 4 main operations that we know in arithmetic. The main one, which is addition, subtraction, multiplication, and what? Division. We'll be taking them pair by pair. So for the addition and subtraction, we can only add or subtract set excuse me, which are similar. Remember the first episode, we talked about similar set. Note, it must first be reduced to their basic form if they are not in their basic form. That will also be understood from the second episode, the basic form of a set. Then this is what we are seeing. Being similar set means that the radicand, the number under the root are the same. So kk. So what I do is just to pick the numbers in front of it as the coefficient. Now, how do I understand it perfectly? Knowing very well that I need to add the numbers in front. Let's just say I let the root of k equals what? Y in the first instance. Then bear in mind the algebraic principles. So this become m times what? K, which is now y, to give us my. This is n times the y, give us what? Ny. So since these are not numbers, we can call variables. We can call the coefficient and variable. I am going to perform factorization. You can see y is common. So I factorize y out. I will be left with m plus n multiplying what? Y. I guess that is okay. M plus y plus n multiplying y. And we say y is the k. So I can rewrite this as m plus n, the root of k. I mean root k. So that is what you are seeing here. So in addition, we just in our mind pick the radicand, the root of the radicand to be a variable. So let's say I'm giving example 1, 2 root 5 plus 3 root 5. I am giving this to add. In my mind, root 5 are the similar set, are the radicands, being the same. So I can pick root 5 as y, meaning 2y plus 3y. That will give me 5y. Then I change the y back into the set. So this will be 2 plus the 3 multiplied by what? Root 5. Just like I am factorizing root 5 out, leaving what is there. And that will give me 8, the root of what? 5. Very simple, right? Good. Now there is a addition here. They say if it is not in the simplest form, we should reduce to the simplest form. So let's see, I've been given example 2. I am to solve or evaluate the root of, let's say, 18 plus the root of, let's say I have 32. You know, this given to you, we cannot be able to add because 18 and 32 are not similar. They're not the same. So first, we need to reduce them to the simplest form, finding their perfect square and non-perfect square factors. So we need a perfect square and a non-perfect square here as a factor, which multiply to give us 18 and 32 respectively. So 2 dividing this is 9. And 9 is what? A perfect square. So I can rewrite this as 9 times 2. 2 dividing this is 16. 16 times 2 is what? 32. And 16 is a perfect square. We've done this in the second episode. So we apply this to be root of 9 times the root of 2, root of 16 times the root of 2. Remember what we did in the second episode? The whole of this is the perfect square, giving us 3 root 2 perfect square 4 root 2. So now you can see that root 2 now is similar. So I only add those in front. I can add it without putting them in a bracket. But if it's in a bracket, it also adds some beauty to it. So this is going to be 3 plus 4 multiplying the root of 2, which will automatically give you 7 root what? 2. Alright, so this is the addition. I'm picking the addition, which is just the same as the subtraction. If this were to be minus, the same procedure follows. It is only here that I will change the cos to become 3 minus 7 instead of 3 plus what? 7. I'm sure the concept is clear. Let's pick more examples to buttress the point. Okay, so let's look at the first one as 3 root 8 plus 2 root 200 plus 2 on 3 root of 162. Alright, so what do we do? Remember, in breaking down this, as the steps continues, as the episode continues, you get to know how we are simplifying the terms. You can vary some of the method along. For example, I can convert this directly to 8 rational and what? Irrational. But we are still in the first aspect of it, so let's continue. So 3, the root of the perfect square here is 4 times 2. This is 200, so 100 times 2 divided by 2, we get 100. Then plus 2 on 3, the root of, if I divide by 2, I'll get 81, and 81 is a perfect square. So as we have done this, remember the perfect squares are the first numbers you have in front. So this is going to be 3, then this becomes 2 root 2, as in this is the perfect square, plus the 2 here, 100 is 10. So times 10, the root of 2, this will be 2 on 3, this is 9, the root of what? 2. So we simplify the terms in front. That will be 3, 2, 6. So 6, the root of 2, 2, 10, 20, the root of 2. Remember, 3 can divide 9. That will be 3 times. 3, 2, 6. So 6, the root of what? 2. So this is a similar set. All have the root 2 in there. So I only pick 6 outside, 20 outside, 6 outside. The root is 2 as I factorize it. So this is 12. So 32 root 2 is your final answer. If you were to simplify that, I guess you get it. Now, if that is true, the B part, you are going to solve the B part and present your answer in the comment section for us to see whether you understood the concept displayed. Like, share, comment, and what? Subscribe.